This time, we're setting out to explore the worlds of the solar system in breathtaking ultra-high definition. This footage was mastered in 4K and in HDR. HDR expands the range of brightness, highlights shine brighter, shadows hold more detail, and the image feels intensely real. Many smartphones support HDR, but a TV is the best choice. You'll enjoy a wider brightness range and an even more beautiful image. Alright, let's set off on the GST tour, so dazzling you won't be able to sleep. The Sun. A colossal body that contains 99.86% of the solar system's total mass. Around it orbit countless objects, planets, dwarf planets, moons, and smaller bodies. The colored lines show their orbits: green for planets, white for small bodies, and blue for comets. We begin with Mercury, the innermost planet in the solar system. Mercury is small, a world of rock. Its surface is covered in countless craters. Meteorites have struck again and again, and with little weathering to erase the scars, those marks remain. The largest impact feature of all is the Caloris Basin. Its diameter reaches about 1,550 kilometers, an overwhelming scale. Here is Hokusai Crater, an impact crater more than 100 kilometers wide. Named after the artist Katsushika Hokusai, it was discovered in 1991 through ground-based radar observations. At its center, mountains rose from the shock, and a high rim swells up around it. Inside and around the crater are classic signs of a massive impact. Melt deposits formed as the crust liquefied under the collision's energy. Radiating outward are some of Mercury's largest bright rays, streaks of pale ejecta. Because these rays remain so distinct, the impact likely wasn't long ago by geological standards. That makes Hokusai an important clue for learning how often impacts happen and how quickly surfaces weather in space. Across Mercury, enormous cliffs stretch for hundreds of kilometers. One of the most gigantic is Discovery rupees. For roughly 650 kilometers, the scarp rises nearly 2 kilometers high. A gigantic wrinkle formed as Mercury cooled and contracted. Its sharp walls run like a spine across the landscape. Leaving Mercury behind, we head to Venus. Venus is the brightest object in the night sky after the Sun and the Moon. One reason is its thick, hot clouds of sulfuric acid, reflecting about 70% of the sunlight. Those clouds are so dense that the surface can't be seen in visible light. So Venus was mapped with radar, wavelengths that can pierce the cloud deck. Beneath the clouds lies a scorching greenhouse world. Across it spread vast volcanic plains and warped mountain ranges. Near Venus's north pole, on Ishtar Terra, rises Maxwell Montes. Its elevation reaches about 11 kilometers, the highest mountain on Venus. Most of Venus is covered in lava plains formed by volcanic activity. There are surprisingly few impact craters, suggesting the surface may have been resurfaced by volcanism relatively recently, perhaps 300 to 600 million years ago. The Moon, Earth's natural satellite. About a quarter of Earth's diameter, it's the largest moon in the solar system relative to its planet. The dark patches visible to the naked eye are the Lunar Maria, plains of rock rich in iron and titanium. By contrast, the brighter regions are made of rocks richer in calcium and aluminum. This is the far side of the moon, the face we never see from Earth. It has fewer Maria and far more bright, rugged highlands. The moon's northern hemisphere. Expansive Maria and intricate terrain. You can also see radial patterns painted by crater ejecta. Tycho crater. Its bright rays stretch for hundreds of kilometers. Overall, the lunar surface is richly sculpted, home to high mountain ranges and deep valleys. Mars, the red planet, is a dry desert world, coated in rock and dust, rich in iron oxide. At its poles are caps of frozen carbon dioxide, dry ice. a gigantic canyon system, Valles Marineris, stretches for 4,000 kilometers. It's carved near Mars's equator. In places it reaches 200 kilometers wide and 7 kilometers deep. Mars is also home to Olympus Mons, the largest volcano in the solar system. It rises to about 25 kilometers in height, more than twice the cruising altitude of a commercial airliner, an astonishing mountain. Its base is so vast that from space it looks like a gentle swell in the planet's crust. Beyond Mars lies Jupiter, but between Mars and Jupiter, there's one more destination we have to visit. The dwarf planet Ceres. About 950 kilometers across, it's a world made of rock and ice. At first glance, it seems like a barren sphere covered in craters. But in 2015, the Dawn spacecraft approached and revealed landscapes unique to Ceres. The greatest highlight is a crater about 80 kilometers wide. Inside, deposits of ice and salt gleam bright white against the darker terrain around them. Jupiter, the largest planet in the solar system. As of the time this video was made, an astonishing 95 moons orbit Jupiter. Its stripes are shaped by clouds of ammonia. In bright regions, rising air piles up ammonia clouds. In darker regions, sinking air thins the clouds. Deeper layers, rich in complex chemicals, show through, giving them a brown tint. Among Jupiter's moons are the 4 discovered by Galileo Galilei, the Galilean moons. The innermost of them is Io. Its surface shows almost no trace of impact craters, an utterly unique world. That's because Io is intensely volcanic. Even if a crater forms, volcanic deposits soon bury it. At night, Io can look hauntingly eerie. Europa is an ice-covered moon. It's slightly smaller than Earth's moon. It has one of the smoothest solid surfaces in the solar system, with elevation changes of only about plus or minus 200 meters. Even in the roughest areas, the relief is only around 1 kilometer. Brown streaks run across the icy crust. And beneath it, a vast ocean of liquid water is thought to exist. Ganymede is the largest of Jupiter's moons, larger even than Mercury. Its surface shows two major terrains, bright regions and dark regions. The reason is still unknown. Ideas include tidal expansion models and a giant impact hypothesis proposed by a Japanese research group. The mystery may be solved by the Jupiter Icy Moons Explorer, JUICE, expected to reach the vicinity of Ganymede in 2034. Callisto, the outermost of the Galilean moons. Its surface is mostly dark, with bright splashes of icy ejecta scattered across it. With little resurfacing from volcanism or tectonics, ancient craters remain, creating the highest crater density in the solar system. The surface has reached saturation. Because even when new craters form, they simply break apart and overlap older ones. Saturn. Adorned with beautiful rings. It has the most moons in the solar system. As of the time this video was made, the number is 274. The rings are made of countless pieces of water ice, ranging from a few meters to a few micrometers in size. Beyond what you can clearly see with the naked eye, sunlight reveals delicate rings at just the right angle, an astonishing sight. One of Saturn's moons is Enceladus. Only about 500 kilometers across, it's small, but its surface is coated in fresh ice, reflecting over 90% of the sun's light. Cracks split the icy crust, and water vapor erupts from within. That material falls back down, snowing over the entire moon. Some of what Enceladus ejects also becomes part of Saturn's rings. Iapetus, like Enceladus, is also an ice-covered moon. But it has a striking two-tone appearance, bright and dark, sharply divided. Saturn's retrograde moon Phoebe sheds dust, forming Saturn's Phoebe ring. As Iapetus plows through that ring, dark material accumulates only on its leading side, creating the world we see today. Uranus. A giant gas planet tinted from pale blue to emerald green. Its rotation is sideways, unique among the 8 major planets. It spins in the opposite direction of its orbit, and its moons orbit in that same unusual orientation, an uncanny, mesmerizing system. Uranus's rings are extremely faint, but when sunlight catches them, they glow into view. Miranda, one of Uranus's moons, is a small world, about 470 kilometers across. Smooth plains, deep valleys, and towering cliffs form a mosaic, often called one of the most complex terrains in the solar system. Verona Rupes drops as much as 20 kilometers. Neptune, the blue giant. Neptune has at least 5 rings. 2 of them are relatively broad, stretching over 2,000 kilometers, and they emerge when lit by sunlight. Neptune's moon Triton was once a dwarf planet-class body from the Kuiper Belt, far beyond Neptune, captured long ago. Its surface is vividly colored: white, blue, green, and pink. Near the equator, strange textures resemble the rind of a muskmelon. Pluto, once counted as a planet, now classified as a dwarf planet. The label changed, but its presence hasn't diminished. For a long time, Pluto existed only in artists' impressions, until New Horizons captured it, and we finally came to know its beauty. A creamy surface dusted with brown like cocoa powder, utterly captivating. It has a nitrogen atmosphere and the haze glows blue. Pluto also has a moon, Charon. Charon is enormous compared with Pluto. So as Charon orbits, Pluto is tugged around dramatically. The two worlds dance around a shared center of gravity. New Horizons also observed Charon's surface. And beyond these, the solar system holds countless other worlds, each with its own unique features and scenery. We live here, on Earth. To experience beauty, we travel to famous sites across our planet. In the same way, when space travel becomes part of everyday life, the list of destinations will be limitless. Before you ever set off on a journey to space, you might even use this saved video to plan your itinerary.